Hello everyone, I'm Mingy Park from Major Electronics. Today I'm going to talk about our work, property-based testing using accelerated SILS simulation. This is a joint work with Hunjang, Taejunbyeon, and our former advisor, Professor Yoonja Choi. Edge home appliances are typical embedded systems which interact with the physical world. Any malfunction can cause physical damage to the user's lives and properties. Any recovery process incurs a tremendous cost because our technicians need to visit every household and update the software. To minimize the potential failure, we perform requirement-based testing as a major software verification method. But this testing used to be hard because of its tight coupling to the hardware. First, we need to operate the physical machine for software verification. It used to take a huge amount of time, as long as weeks, for testing a single cycle of the refrigerator. Second, test inputs had to be constructed manually, which is expensive. And third, our testers need to watch the entire test process and check the result manually, which is error-prone. With the software engineering research experience, we thought we can do a better job. We wanted to learn more inputs, learn it fast, and check it more thoroughly. We could achieve these goals by bringing all the techniques proved to be effective in research, but yet to be applied in mass production. To achieve our goals, we built this framework for automated requirement-based testing in system level. This framework consists of the three components. First, the accelerated SILS simulator, which resolves hardware dependencies and reduces the execution time. Second, the combinatorial input generator, which creates a large amount of test inputs. And third, automated property checker, which continuously monitors the test execution for a property violation. Alright, let me go deeper into the simulator first. In our previous practice, software development couldn't even start before the prototype product is made. With the SILS simulator, software can be developed in parallel with the hardware, easing pressure on the software development and verification schedule. But applying SILS alone cannot reduce the execution time unless the notion of the time is abstracted. This can be tricky in embedded systems where the time is dictated by hardware. Since the global time is recognized through ISR issued by the hardware clock, we inject the ISR into the main loop to virtualize and abstract the hardware clock. As a result, each main loop iteration means a virtual time passed, and the execution could be accelerated significantly. The second part is the combinatorial input generation. We first construct the test scenario template from software requirement and generate combinatorial inputs using pairwise method. Each test sequence is translated into an input state machine. The third part is the automated property checking. It used to be done manually, but it can be done automatically and more thoroughly. The properties were derived from the history of critical failures in AGE. Most of them were categorized as safety or liveness property. We formalized 90% of them into linear temporal logic. Once the properties are formalized to LTL, we can easily translate them into Buki automata and then synthesize monitors in C code. The monitors learn in parallel with the target system and check the state variables in target system to flag any property violation. So that was for the tool. A fast simulation, large amount of test inputs, and strong outputs. We applied this framework for verifying our various products in AGE. Here we present two field applications, one with a washing machine and another with a kimchi refrigerator. The targets already achieved 100% branch coverage in unit testing. This slide shows the gain in efficiency. In washing machine, half an hour cycle is done in 70 seconds, and in refrigerator, about 2.5 day cycle is done in 20 seconds. When compared with manual testing, 84 times more test inputs are tested in 3 times faster in washing machine, and in refrigerator, 26 times more test inputs are tested in 15 times faster. Let me show you a quick demo. It is a washing machine simulator. 1 hour cycle is done in about 4 seconds, and it is 1,000-fold acceleration than real product. For the thoroughness, we achieved 37% higher branch coverage on washing machines and 72% higher on refrigerator. And we found a property failure case per each product. It would cost tens of $1 million each if it was found until after sale. This slide shows one of the failures. Washing stage, rinse and wash was inverted. Washing machine uses heat to implement the scheduler. This bug was caused by a developer's mistake of adding an invalid heap operation. Let me show you a quick demo. Washing stages are inverted in specific option. Add swap option, remove spin option, and re-add spin option, and start the machine. After swap, rinse stage is operated instead of wash. After rinse stage, wash stage is operated. After this cycle, detergent will still remain in your clothes. Conclusion. We applied automated requirement-based testing in the system level by accelerated SILS, combinatorial method, and synchronous observer. As a result, we found 2 property failure cases in real product. The result demonstrates that property-based testing can create a powerful synergy when combined with acceleration and the combinatorial method. Finally, I want to share our lessons with the community. Internal inertia was the biggest challenge for us. Company was unwilling to invest in this research, but we took it as a side project in our leisure time over the past 2 years. With our success, it was widely adopted company-wide. The key factor behind our success was the existing verification properties. AGE was keeping field failure cases over the past decades. We could easily turn them into synchronous observers, which eventually found failures. Finally, I want to emphasize that we need more advanced system-level testing techniques. It is currently the most labor-intensive verification process. Any automation or improvement can bring a huge benefit in the industry. This is a presentation of our works. Thank you.